So we're on part C, I believe. Yes. Okay. So we talked about up here, we talked about the distribution being skewed right. It is possible that it's bimodal. There are two modes. Um, but remember, we took a sample of 50 from a population. So it's not always going to be, the sample distribution is not always going to be exactly the same as the population distribution. So it is possible that there are, you know, if this were just to slide over a little bit, you'd see it's got the concentration right there. So it could be two modes. It could be one big mode that's got more of a hill type of thing. So it's challenging to be sure. If you said bimodal and skewed right, I'd have to give it to you. If you just said skewed right, one mode, that would work as well, one hill. All right, let's get back to C. So a sampling distribution, it's not appropriate to use mean as the point estimate for center because the mean will get pulled out by these values. So the mean might go over to 3,000 when actually the center is a little bit closer to the middle here, like 2,700. Okay, so got to be careful. We got to know that. We got to demonstrate that knowledge, which we did on the other one. All right, now we're into sampling distribution. I don't know what they're talking about at first. That is typical for an investigative task. Fortunately for us this year, they took that investigative task out. So it is things that you prepared for. They're probably, thinking that it's stressful enough to be taking it under testing conditions we're not used to. So they took this out. But it's good to learn what you should learn in this course. And who knows, this could be useful. They could throw something like this at you, and we'll just have some exposure to it. So sampling distribution in general, you should be able to talk about. If you can't talk about what a sampling distribution is, you're going to miss out on a part of the points. So sampling distribution is a collection of all the possible sample statistics from every possible sample of the same size. Okay. So if you could collect every possible sample of 50 from the entire population and get all the medians from them, theoretically, that's the sampling distribution. It'll never happen. Okay. So that's the theoretical sampling distribution. Now we're trying to get as many sample medians as possible. We're trying to simulate that. 15,000 is a lot. Okay. So, that's pretty good work there. Now, okay, what did I get into? We want a confidence interval. So here's what I was looking at. I was thinking, after I said what the sampling distribution is, now I got P because I've already demonstrated that content knowledge. Now let's go specific. For our confidence intervals for means or proportions, which we usually work with, we would typically go 90 or 95. Well, I'm just going to choose 90%. Okay, I could have chosen 95, but 90% seems good to work with here. So basically what we want to do is we want to cut off the lowest 750 and the highest 750 from this table. And what I mean by that is if we add these up until we get to 750, we cut that off. It's the same thing as cutting off the tails in a normal distribution. So the outside 5%, right? So basically what we're trying to do is let's try to cut off the outside 5%, the lowest 5%, and then get a number. It's going to be somewhere in here. Then we're going to cut off the highest 5% and get a number somewhere in that range. Okay, so now precisely what it is, if you do 5% or 10, well, let's say we do 5% of 15,000, it's 750. So what I did, so that it wasn't so tedious, you didn't have to watch me do that, is I started adding these up, and I got to here, it was 408. Well, of course, this is going to take me beyond the 750 mark. So basically, if I use 2,500, I can cut off at least, 5%. there's less than 5% below the 2,500 mark. Okay. And then if I cut all these off, I found right there, okay, I got up to 750 when I added that in. Okay, so then that was like a 200 or 188 or something. So then I went over my 750 mark when I added that in. Okay, so if I cut these off, I'm cutting off not quite the full bottom 5%. Okay, if I cut that off, I'm cutting off more than 5%. I don't want to do that either. So basically what I said was, okay, I know that 2,500 to 2,950 gets us at least a 95 or a 90% confidence interval. I know that. Okay, and that's what I was going for. So good enough. Next, well, so what I ended up finding out was I got really lucky there. I did find the 5th percentile, but I got to show that again. 0.05 or 5% of 1,500 to 750. It ended up being the same thing I worked up there, but your way again of getting a P is to talk about and demonstrate your content knowledge of percentiles. The percentile is a point in the distribution that is greater than or equal to the given percent of the rest of the distribution. Okay, so basically you got to find a value that is better than the lowest 5% of the data, and that's basically what's happening. And that happened to be the 2,500 again. Now, why does that happen? Well, because when we go up here, okay, we get to 408 right here. It's not quite 750, but this takes us over the 750 mark when you do the cumulative frequencies. Okay. So the 5th percentile is at 2,500 because that value is greater than or equal to the lowest 750. So one of the 2,500s, there's so many of them, but one of the 2,500s, so like if you go almost 300 of the 2,500s, all right, you'll get to the 750th in order, if we were to put them all in order. So yeah, that's the 5th percentile. And then again, it ended up being the same thing that we did on the top side, but show it. 0.95 times 15,000 is 14,658. Now, we didn't do that. We didn't add all these until we get to 14,658. Okay, what we did instead was we just added backwards. We went backwards to 750, and that put us over. So 2,950 ended up being somewhere in there was the 95th percentile. Okay. Find the percentage of medians that, okay. So what I did was I added up all the low ones, 408. I added up all the ones above our 2,950. That was 188. We found out that was 96. That was 4% of the data was outside. 96% of the data was between those markers, including at or between. So when you include the 2,500 and the 2,950, as well as everything in between, it'll be 96% of the data. Okay, so we did know that at least 90% of the data was in this interval. Okay, and we found out afterwards that 96% of the sample medians were between these two values. Okay, so now we construct that confidence interval. All right, now let's interpret that. Okay, so the key to this is really you've got to make sure that you interpret this. All right. So what I'm going to talk about is the 15,000 sample medians used to create this 96% confidence interval for the true population the true population median. If we repeat this process for all possible sample medians, if we could repeat this process, all the possible 96%, sorry, 96% of 96% of all the possible intervals of the same would capture the true population median. Let's see if that makes sense. Yes. So we constructed it. Yeah, I'm pretty confident in this. This is how we would do it if it was a mean. If we could repeat the process for all possible sample means, is usually what we do. We would predict that 96% of all the possible intervals would capture the true population median. Okay, so I'm going to say that that's good enough. I've never seen that question before, so hopefully that is sufficient. Thanks so much for tuning in, and good luck on your AP exam tomorrow.